welcome to video number 3 in this series. Um, in this video, we're going to talk about data types and variables in Python. And you can think of a variable as a container that holds a value, okay, or an object inside of it. It could be an integer, a number. It could be a decimal value, a float. It could be a string of text or a dictionary or a tuple or a list or an array type object. It could be an instantiated object from a class that you've defined, an object that you built yourself. But basically, it's one of the most basic components in Python or pretty much any programming language if we're going to manipulate and create and store variables. And there's a couple of different data types in Python. Some languages are loosely defined in the way they deal with data types. And that could be a language like Visual Basic. You can just pretty much create a variable and it's implicitly given a data type based on how you use it. You don't have to predefine the data type. C++ is very different. It's a strongly typed language. And because it's strongly typed, you have to specifically define a variable as an integer if it's going to hold a whole number, or a float if it were going to hold a decimal value, or a string or a character array. And that's one of the things that gives C++ so much power and efficiency, and how it manages memory, and why it's maybe 20 to 30 times faster than Python or Visual Basic or a lot of other languages. So the trade is a bit of complexity. You have to plan out your data types and you have to predefine them in C++. In Python, you can do that. You can predefine a data type, but you can also implicitly define a data type. So Python can automatically assign that data type based on how you use the variable, how it's defined. You can also explicitly do it using various methods in Python. And we'll look at both ways of doing that. Okay, so again, to go over some basic Python data types, and you'll find these in other languages like C++ and Java too. But numeric would be integer, float, complex. String, of course, a string. Sequence, lists, tuples, range. Think iterables, array type objects. Binary, bytes, byte array, memory view, mapping, dictionary, and Boolean, which is just a true or false value, bool. Let's be bullish. That's my cat in the background. He's got dementia. He's howling. But all right, we're going to take a look at a couple of functions here, and I've just defined these in functions to make them easy to execute. And while we're at it, let's go over several ways of doing things in Visual Studio Code. So down here, I'm calling these functions, and I've commented out the ones that I don't want to execute. So variables O1, that's this function up here, and if I wanted to run it, all I have to do is hit F5, because that's the only one that's not commented out. And then it would display down here in the console. We can do it that way. We can copy and paste it here in a separate file and run it. And that's what I'm going to do with a lot of these examples so that you can hopefully see the code better and see how it works. So I'll just copy and paste the function that I've written over here, and then we'll run it. And that way we can focus on that little block of code, one block of code at a time. And I think that makes it easier to learn and to focus. There's also something else you can do in Python. If you highlight a selection of code, such as in this function here, I can go and I can come down here and I can say run an interactive window. And now I'm going to say run selection. So just showing you that if you write your code in well-defined modular functions, you can highlight blocks of it in Visual Studio Code, right-click, then you can say run an interactive window, and run selection line and interactive window, or from line, if you want to run from that line. So that's kind of a neat capability. So we're going to run this first method here. And so all these are commented out. We're just going to run variables O1. And I'm just showing you here, this is how we would implicitly define a data type in Python. So I have three variables here, x, y, z. And the first one, I'm assigning a string literal value in double quotes of 444. And the next one, I'm assigning a whole number integer value of 444. And finally, in the last one, z, I'm assigning a decimal value. So implicitly, Python's going to give the data type of string to x, a data type of integer to y, and a data type of float to z, just based on how I've defined them or how I have initialized them. And I'm using the type method right here. Okay, the type method will just render the data type of the variable that you pass in as a parameter or an argument. So let's go ahead and run this. I'm going to hit F5. Let me clear down here. We'll hit F5. And I'm going to pull this over here. Give us a little more screen real estate. Okay, so implicitly setting the data type of a variable, Python chooses, and then in this case, notice the type here. In this class string, class integer, class float, well, what's rendered by the type method, that was implicitly given to the variable, okay? Implicitly assigned. So Python automatically chose the data type based on the value that I chose to store in the variable itself. Let's take a look at our next function here. Let's look at explicitly defining a data type or variable. Okay, and we'll clear the console there. All right, in this instance, I'm going to use several methods to explicitly, rather than implicitly, define the data type. And this is useful sometimes for improving efficiency. And sometimes when you're working with different classes and methods, you need to use a certain data type. You don't want to implicitly, you want to explicitly define it. Well, in this instance, by passing 444 into string, all right, it's going to be explicitly assign the data type of string. And if I pass it into integer, it'll be assigned to an integer, a whole number value. And float, even though I don't have a decimal value in this case, because I'm explicitly passing it into float, it's going to be defined as a float. And we can see that by the types here. So let's go down and we'll comment this out and uncomment function 2. And let's see what happens when we run 2 here. Okay, so again, I'm going to hit F5. Okay, and when I call the type method, just as I did in the first function, now we're in function variables 2. Look, the class is string, integer, and float. So in the first example, it was implicit. In the second example, it is explicit. Okay, let's take a look at function 3. Let's look at integer and float variables used in expressions. Okay, so x, y, z, we've defined some values here, and don't need a semicolon, but for consistency, I'll add one. So the result, we're going to multiply x by y by z. We're just doing some simple basic math with these variables, okay? And these would all be integer values because implicitly the value that I stored was a simple whole number, no decimals, and not very large. On the other hand, these, because they have decimal values, numbers to the right of the decimal point, they would be implicitly assigned the data type of float. And we can still do an expression, still do math. So we'll multiply a by b by c here, just like we did x by y by z. But in this case, instead of integers, it's floats. And we're just going to display the results here, okay? We'll display the results down here, and then we're setting this not to automatically add a separator of white space because it would mess up our spacing. In this case, we want to define our spacing ourselves. So let's go run this method, and we will comment out variables 2 and uncomment variables 3. And let me scroll up here so you can see the code. And I'm just going to clear the console here, hit F5 and run it. Okay, and so you can see the result of our expression. And the result of our expression. Okay, so just an example of how you would use variables in an expression. Let me clear this for the next method. And the next method down here, we're going to concatenate some string variables. Concatenation is cool. It's what we would call in C++ operator overloading, where you can take a basic mathematical operator, such as the addition symbol, or subtraction, multiplication, and so forth, and you can create a function that overrides the basic mathematical process. So yeah, I'm using the addition operator, but instead of adding numbers and getting the result, I could bring two strings and put them together, concatenate them together. And that is a very powerful feature in any programming language. And in Python, you can do that as well. However, when you are concatenating, the variables have to be of the same data type. So if I'm going to concatenate and put two strings together, the value on the left side of the expression and the value on the right side of the expression have to both be strings. And then I can concatenate or link them together. But if this were a string and this were a float or an integer, I'd have a problem because they're not the same data type. Now the print method, that will take care of it for you if you're not concatenating. If I were to just use an integer or a float with a string, it automatically does the casting or the typecasting between data types. But if I'm concatenating inside the print method, as we'll see, then I have to typecast or cast a different data type, such as an integer or a float. I'd have to cast it to a string before I could then concatenate it to another string. Otherwise, I would generate a type error. So let's look at first a basic example of concatenating strings together. So I have a name here, Carly Solali, Germany, okay? First name, middle name, last name. So full name, we're going to concatenate these three strings together, okay? So these three will become one. And first name plus middle name plus last name. And we're going to insert a little bit of white space in between them. And we'll just display the result. So let's go and uncomment 4 and comment out 3 there. So let's go ahead and run 4 here, okay, and see what happens. Hit F5. So you can see I have 3 strings, Carly, Soleli, Germany. But when I concatenate them all together, I take this string and connect it, combine it with this string, and then combine it with the third string, okay? So let's take a look at another example. Now here we're going to create or throw an error on purpose, throw an exception and error on purpose. We're going to generate a type error. I'll show you what happens if you try to concatenate 2 different data types together. All right, so data types are important. Let's go uncomment 5 here and let's blow up our computer. Not as bad as a divide by 0 error, but still. We don't want to concatenate different data types. That's a no-no. And what happens? Well, watch. If I hit F5, see? Exception has occurred. Type error. Why? What's going on? Well, look at what Visual Studio Code is highlighted here. See, I'm trying to concatenate a string literal, my age is, to my age. Well, what is my age? My age is an integer. It's not a string. It's not in double quotes. It's a whole number. It's an integer data type. So I have 2 different data types going on here. This string literal right here and this integer right here. And if I don't cast or typecast that integer to a string, I cannot concatenate it together to another string, okay? So just an example of generating a type error on purpose. Let's go on to our next function here. I like to do everything in functions, and it makes it so easy to organize and modularize. Is that a word? Modularize your code. But, all right, let's look at casting one data type to another successfully this time without that type error, generating that type error. So here we have my age. It's a whole number integer value. Here we have my temperature. It's a float value, right? Because it's a decimal value. And, these consume different amounts of memory. So in this case, an integer data type consumes less memory than a float data type because it takes more bytes to hold the decimal portion of a value or to exceed the value that can be held in a whole number integer. So Here we have some code using the print method without string concatenation. I'm going to show you that if you do it this way, the print method will implicitly cast it for you. All right, it'll do the typecasting automatically, and it'll do it all for you if I use a comma. But on the other hand, if I'm going to concatenate within the print statement as I'm doing down here under section B, then I need to cast. And the way I do that, I just use the data type method. So to convert anything to a string, I have to pass it in as a parameter or an argument to the string method. And we're going to go over functions and arguments and parameters in another video soon. So just kind of put that on the shelf for now if that seems weird or confusing or new to you. We're going to go over it. But right now we're just making use of the string method to cast that value, right? Because data types are important. So it's not a string, it's an integer. And if I'm going to concatenate it with the overloaded addition operator here, I have to first convert the data type to a compatible data type, which has to be a string. So I pass it into the string function here, the string method, and in the parentheses, my age, that's my integer up here, it will get converted to a string. And then I can concatenate it. And that would be just the same as in double quotes if I put 53 and it were a string literal instead of a whole number integer. I'm going to do the same thing with my temperature. My temperature is a float, right? Because it's a decimal value up here. But I'm going to cast it, all right? And if I typecast it by passing it in as a parameter or an argument to the string method, it'll convert its data type from float to string. And then, because both of them will be strings, I can concatenate or join them together. Okay, very powerful feature in any programming language. So let's go run this function and see what it does. Okay, I already uncommented. And I'm going to hit F5. All right, so notice the first time in the print statement, it does it for us. It does the conversion for us automatically. But here we can concatenate in the bottom in section B. My age is 53. It still works, and it doesn't generate a type error now because we are typecasting. We're casting the integer data type to a string. We're casting the float data type to a string. And now we can put those two strings together in the print method and display the data. Okay, so I hope you're getting used to the idea of working with variables. Different variables, think of them like different containers. You know, those Glad plastic containers you store food in. Well, some of them are small. You can hold your gravy and you can hold your cranberry sauce. Others of them are large and they can hold all the turkey bits and leftovers from a Thanksgiving dinner or all the stuffing in your mashed potatoes. So variables are like that. Think of them as containers that hold different quantities or servings of food, okay? Some of them use smaller amounts of memory, such as an integer or a bool, which is just true or false. Others can use larger amounts of memory, which is like a string object, which is really a whole array of type characters, could be composed of even hundreds of characters, and so would consume more memory. Or it could be a very large number with a very precise decimal point value, and so a float would consume more memory. It would be a larger container than an integer. So data types are important, and variables have different data types in Python, just as in other languages like Java and C++. And let's go look at 7 here. 7, we're just going to use some booleans, okay? So I have an integer that I set up called my age right here, and then am self-aware, and that's false. Because for most of my life, I really wasn't self-aware. I kind of went through life as a robot, no free will, no. I think most people at teenagers achieved what I didn't achieve until maybe my late 40s or 50s. But hey, some of us get to the party late. We print, and then we have a simple decision structure here. And we're going to go over if and else decision structures in the following videos. So we'll go over loop repetition structures. So again, if this is new or confusing to you, just hold that, put that on the shelf, because we're going to go deeper into these topics in upcoming videos, okay? And if this is not your first programming language, you are probably very familiar with if and else and decision structures. But just to show you a Boolean data type, let's be bullish. We're so bullish. Okay, well, I know. But it's either true or it's false. The bit is on or the bit is off, okay? That's really the only purpose of a Boolean. It doesn't take a lot of memory to store a Boolean, but it can be very useful in logic structures. And so if my age is greater than or equal to 45, I'm saying, then I'm going to set am self-aware to true. I woke up. I realized, hey, I'm not just a robot. I do have free will. I can make my own choices about some things in life. And then down here, I'm saying, look, if am self-aware, that's a shorthand way of saying if am self-aware evaluates to be true, okay? And evaluates is different from assignment. Remember we said that this is not equals, it's assignment? Well, this is sort of the programming equivalent of the mathematical equals. It's two equal symbols together side by side, and it performs a test. It evaluates, okay? And so it would examine the value, the Boolean value stored in am self-aware. If I am self-aware, if it's set to be true, then this will happen. I achieved consciousness long after most. For most of my life, I was a robot without free will, okay? And the only other possibility, if it's not true, since it's a Boolean, it has to be false. So if it's false, I'll say I am not yet aware of myself. Most others take this for granted. But just to show you the true false nature of a Boolean data type variable, we will run this method. So we're all set here. And again, I'm going to clear the console down here, and I'll hit F5. And there, I achieved consciousness long after most. For most of my life, I was a robot without free will. Why? Because this variable, am self-aware, was set to be true. Why? Because I had attained or reached the age of 45. Most people develop this sort of consciousness around the age of 12, I think. But maybe I was a little late to the party. But I hope that demonstrates in an easy to follow and understand fashion variables. All right, why are there different data types? Why do they consume different amounts of memory? Why, why are they different sizes? Okay, so thank you for watching. And the code for these examples will be in a link below in the description tag. And they're all hosted on GitHub. So you can go to GitHub and you can download the code. You can load it up into Visual Studio Code and your Anaconda Python, and you can run it and see how it works. See what makes it tick. I recommend that. There are different ways of learning. Some people are visual learners. They just learn by watching. Some people are auditory type learners. They can learn by listening. They listen to audiobooks and podcasts. A lot of people are tactile or kinesthetic learners. That's me. I don't learn unless I do it. I have to go through the motions and be mechanical about it. So you can talk and talk and talk about code all you want, and it kind of goes in one ear and out the other with me. I have to actually manipulate the code. I have to type it in and play with it and break it and fix it and break it and fix it and modify it and warp it and twist it. And then I begin to remember and I begin to understand what's going on. So if you're that type of learner, if you're a kinesthetic, tactile type of learner, hands-on, you got to do it. You can't just see it. Then grab the code off GitHub and, break it and fix it and twist it and warp it, and then it'll stick. Better yet, type it in and modify it, season it to your tastes. So whatever your learning style is, that's available for you if you happen to be a kinesthetic type of person, right there on GitHub. Just look for the links below in the description tab. Well, thank you for watching, and if you like this series of videos and you'd like to see more, please subscribe and hit the notification bell. See you in the next video.